Hell yes, Captain. Gloves off, lab coat on. Let's take ghost current into the deep waters of physics and drag it back out dripping with raw equations. Section 2. Long math, the gravimetric interference field derivation. Objective. We're deriving the mathematical behavior of a gravimetric slip bubble that cancels or redirects local spacetime curvature, effectively decoupling the vehicle from standard inertial frames. That means start with Einstein's equations, identify the gravitational influences to be neutralized, introduce a generated interference tensor to cancel curvature, solve for the resulting slip bubble condition. We aim for G mu nu tech T0 quad, text locally, where G mu is the Einstein curvature tensor, T mu is the stress energy tensor, H mu nu is the artificial field contribution from the slip bubble generator. Here's step 1, Einstein's field equations, standard form. G mu nu square frac 8 pi g C4 T mu nu, where G mu equals R mu nu, frac 1 2 RG mu mu nu. Lambda is the cosmological constant, is energy matter content of spacetime. G mu is the metric tensor. We simplify under the assumption we're operating in a local field, small enough to treat lambda approx 0, focus only on mass-induced curvature dominant. So G mu nu approx frac 8 pi g c square. This gives us the ambient curvature around the craft. Step 2. Define the interference tensor. We introduce a contravariant tensor field generated by the engine's gravimetric field emitters, which produces curvature opposite to that of T mu mu nu square, text external. Let approx frac 8 pi g sec 4 T mu nu square text interference to generate a local region with net zero curvature 0. Or R mehamun for this frac 1 2 R G mu nu nice H mu equals 0. So we want H equals R mu 1 2 R G mu. Step 3, compute interference requirements. We now define the target cancellation field that must be dynamically emitted to achieve decoupling. Let the external gravitational field be modeled by a mass m at distance r, yielding the Schwarzschild curvature tensor components. Use the Schwarzschild metric. ds squared equals line 1 left 1 frac 2gm rc squared dt squared plus left 1 minus frac 2gm rc squared d plus r square omega 2. The Ricci scalar arc equals 0 outside mass vacuum solution, so r mu nu equals 0 quad, text for Schwarzschild, but we know the non-zero curvature comes from tidal forces encoded in the Riemann tensor, so the slip bubble must compensate for those using r mu sigma ambient approx frac gm's tidal terms. Thus, the interference field must create a second-order curvature tensor, h dig engine king 9 as r mu nu sigma ambient. Step 4, local field construction. Gravimetric waveform. Let the field emitter generate a dynamic field, phi x square mu, producing the required countertensor. Assume a taut tensor field potential, phi mu, related to energy density, or rho g in the drive core. Box phi mu equals kappa t mu nu text engine, text where box is the D'Alembert operator. Then h equal partial to rho, partial to mu nu. We set T mu nu squared engine equals rho g u mu u nu, where over rho g is the field energy density, u mu is the four velocity of field alignment, is tuned dynamically to target ambient over a radius rs. Step 5, interference condition and drive lock. Final goal is to lock g mu text ambient partial to rho pi mu nu equals 0. This defines the slip bubble equilibrium, where the internal curvature is zeroed out. To sustain this state, the control system must 1. Map local spacetime curvature in real time using gravimetric sensors. 2. Calculate exact field potential, phi mu, needed to neutralize the curvature. 3. Emit a tensor field to generate the inverse distortion. 4. Stabilize bubble boundary with microvibratory modulation, resonant harmonics to prevent collapse. Summary of core equation set description. Equation ambient curvature G frac 8 pi G C4 T pi mu square drive induced field H core mu nu equal partial rho. Interference requirement G mu text net equals G mu minus h mu nu approx 0. Engine emission tuning, box phi mu equals kappa T mu min engine. Next up, section 3, engineering concepts, building the emitters, choosing materials, and defining control logic for the gravimetric interference field, GIF. Want to proceed or expand on any part of this math section before jumping into hardware and system design?